A convenient way to deal with vectors is by writing them in component form. To do that, we need to start off with the idea of unit vectors, I and j. Now, this is written I, but it's not the imaginary unit, which is also I, because this is a vector and it's not written stylized. So I is a unit vector that goes 1 unit to the right. This is I right here. J is a vector that goes 1 unit up. So any vector can be written as a linear combination of I and j. So any vector v can be written as a times the unit vector I plus b times the unit vector j. So for example, if I write vector v equals negative 3i plus 6j, what that means is I have a vector that goes negative 3 in this direction, so negative 3 to the left, and it goes 6 up. So if I put this over here, and this is my starting location, I go 1, 2, 3 this way, negative 3i, and plus 6j, 1, 2, 3, 4, 5, 6. Oops, got a little close to my text, but that is fine. So then my vector v is just the total of those two, so it looks like this. This is my vector v in component form. Now, the magnitude of a vector is often written as double vertical strokes around v. Now, it kind of looks like absolute value, and it's kind of a related idea, but the notation is a little more complicated. But the idea is sort of essentially the same here, and it's sort of similar to R if you're dealing with right triangles or complex numbers or really anything where you have a picture like this, of which we've seen several examples so far this term. So to calculate the magnitude of a vector, it's not very difficult to understand what you're going to do here. You're just going to use the Pythagorean theorem. You have some amount the vector goes A and in the right and left, and some amount it goes up and down B. So that's just the square root of A squared plus B squared. Some other books give these as xi plus yj, but it doesn't matter. It's just the Pythagorean theorem for the magnitude. And the direction can be given as an angle in standard position, which again we will call theta. And theta you can calculate using the inverse tangent of b over a. But we have to add the usual caveat, because whenever we use inverse trig, there's a chance we're not going to get the number in the right quadrant we want. So plus pi radians or plus 180 degrees if the vector points into Q2 or Q3. So as an example, let's find the magnitude and direction of this vector v was negative 3i plus 6j over here. So the magnitude, right, with those double vertical slashes like that, and just do the square root of a squared plus b squared. So a is negative 3 squared, but as usual, if you square a negative, it's going to make it positive, so you don't need that. You don't necessarily need to write that, but it's helpful if you are just starting off here. And that is supposed to be a 6 squared. Now notice that it's just a and b. A and b are the numbers, not the i's and j's. The i's and j's play no part in this. This is just a convenient way of writing it in terms of right, left, and up, down amount. But they do not play into this formula at all. So you get the square root of 9 plus 36 is the square root of 45, which of course you can simplify that because 9 goes into that. 9 times 5 equals 3 square root of 5 is the magnitude of vector v. Now for the direction, just do theta equals inverse tangent of negative 6 over 3 or inverse tangent of negative 2. But now this vector we saw over here does point into quadrant 2 if we think about the origin being here and we have this here. This angle would be a quadrant 2 angle, so we do need to add the 180 degrees here. So grab your calculator, work that out, and you'll get 116.6 degrees, and that's all there is to it. Now, if you want to go the other way, you have the magnitude and direction, and you want to go into component form, you just use our trigonometry. So A is going to be equal to the magnitude of V times the cosine of the angle, and b is going to be the magnitude of v times the sine of the angle. So, for example, for vector w, we know the magnitude of vector w is 10, and theta equals pi over 3. Write this in a times I plus b times j form is easy enough. You just do a equals 10 times the cosine of pi over 3, which we know that is equal to a half. So we get a is equal to 5. we get b is equal to 10 times the sine of pi over 3. Now we know the sine of pi over 3 is root 3 over 2, so we cancel and multiply there. We get 5 root 3 for b. So we just write vector w is equal to 5 times I plus 5 root 3 times j.